Okay, so we are going to start where we pick up where we left off, which was, we did that, right? And I'll make this bigger in just a second once we find out where we were. Did we do that one? Yeah, we did the conditional, right? We didn't do that one? Okay. Okay, so we're going to write this down. So we're going to fill in the blank here. So, you what? For really reals? I said we did everything, Anthony. That's as good as I can go. So we're going to do the stuff that we did yesterday based on this statement right here. So we're starting with the conditional statement, which says if the measure of angle B is 45 degrees, then angle B is acute. So you need to write that down, and we're going to fill in the table.
Angle B is acute, then the measure of angle.
Okay, good. So the converse is, flip it around.
Angle B is acute.
Then the measure of angle B is 45 degrees. Okay.
Write all this down?
Yeah, do you have to go like
Write all this down. You can abbreviate it or, you know, whatever, grow up. Not a big deal. How do you, what? Yeah, then we're going to figure out the true false part too. Then there's the inverse also. So she said the converse, which is that if angle B is acute, then it's 45 degrees. The inverse is you do what to it? Make them both negative, put not in front. So if the measure of angle B is not 45 degrees, then angle B is not acute. And the contrapositive, what do you do for that? Put not and switch the negative. So if angle B is not acute,
Can you write that down?
then its measure is not 45 degrees. OMG, you guys are hilarious. So if angle B is, the problem with me writing it down is when I do it on this, my pen through my board freaks out. If angle B is acute, then, see what's going on there. That's what I wrote. Then it equals 45 degrees. Go. So that's the converse because we flipped them around.
So I just put if the measure of angle B is not 45.
I'm going to shorten a little bit here. Then if not 45 degrees,
If not.
then not acute. Right? And then, if not 45 degrees, then not acute. Does this say then?
Yeah.
Yeah. Can't you read?
Wait, what's the contrary?
And then the contrapositive is the combination of these two right here. You flip them around and make it negative. So
if
if
not acute,
not acute, you know what? You make me tired. Then not 45 degrees. Someday very soon, hopefully, all of you will be in college classes. In a college classroom, the professor just stands up there for an hour or longer and just blah, 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 blah. So that's what he used to do.
Do I have to write down?
Yeah, I should get home. You're nice to me, they wouldn't have to. First rule of teaching. The student says, do we have to? The answer is always yes. And if the student says, can we? The answer is always yes. Because if you say, do we have to? You're trying to get away with doing less than you really should. And if you say, can we? You know already you shouldn't be doing it, but you're trying to see if you can get away with it.
so can we go outside? we have to do this?
We have to go outside. That fits my kid. Yeah, he's got it figured out. Okay, so now let's talk about the truth value of these. The first one says if the measure of angle B is 45 degrees, then angle B is acute. True or false? True. Next one says if angle B is acute, then it equals 45 degrees. True or false? False. Not necessarily. Could be the case, but doesn't have to be.
No.
And the next one, if an angle is not 45 degrees, then it's not acute. That is also false.
So the next one's true.
And the last one, if an angle is not acute, then its measure cannot be 45 degrees. That is true. So we talked about that yesterday. The conditional and the contrapositive will always have the same truth value, and the converse and the inverse will always have the same truth value as well. Does that make sense? Yes, Mr. Aldrich. Okay, so now let's play again.
What do you do?
So this conditional statement says if two angles are vertical angles, then they are congruent. Okay?
Write that down.
And then this says, no, we're going to just write down the answers because we're being crabby. Determine the truth value of the conditional statement and its converse. So what is the truth value of this statement? If two angles are vertical angles and they are congruent, that is true. I'm sure Jennifer was just kidding.
Wait, hold on.
Hold on, I wrote the letter T on the board. Is that too much for you?
See our papers, but we know what that means.
Okay, go. I'm answering the question. Is this true or false? Oh, there you go. All right, then it says what's the truth value of the converse, and so what's the converse? Right, if two angles are congruent, then they are vertical. Is that true or false?
False.
That's false. What would be a counterexample to that?
I don't know.
It says write a counterexample if needed. So give me two angles that are congruent, that are not vertical angles. Okay, one over here, so I got a party over here. And I got a party over there. Okay, is that what you meant? Okay, and what's the degree measure of each one of these?
35.
40. Okay, so here is an example of two angles that are congruent, but they're not vertical angles. Okay? No, you must write everything I write on the board, exactly and only.
Unless you want to fail this test.
Yeah, you should draw that.
This is a practice test? Oh.
This is the practice test. Okay, we good? All right. So it looks like we're still playing with this same simple idea. Write the converse, inverse, contrapositive, and say whether they are. Did we do this one yesterday?
Yeah.
Ah. So we did this one, right?
Yeah.
Okay, so we don't have to do that. Right. Okay, so we got the.
Please stand up.
Right now?
Would have been better if you guys got eyebrows.
These are the undefined terms in geometry. A point, a line, and a plane are the three things that you can't really come up with a definition for it because, you know, a point has no size. That doesn't really make any sense. Those are things that we talked about at the very beginning of class. Then you use that to come up with definitions, postulates, and theorems. A definition is a statement that uses undefined terms or other definitions. Since Anthony's gone, we can zoom out a little bit. There we go. A definition is a statement that uses undefined terms and other definitions to describe a mathematical object. A postulate, which is not something we spend a lot of time talking about, is a statement that is accepted as true without proof. What's one of the postulates we came across in our packet? Well, then don't answer. Oh, that usually goes. Thank you. Okay, so one of the postulates that we talked about yesterday is that if you have 2 points that are in a plane, if you draw a line that has both those points in it, it'll be in the same plane. as the points. Duh. And then a theorem, which what your books refer to more often as a conjecture, is any statement that you can prove. And then as soon as you can use it, you can use it, or as soon as you prove it, you can use it again later. Okay? So we went through these,
Can
right?
you go up really quick?
Two. Go.
On the page.
Do back flip.
To what?
Do back flip. Get crazy.
To what? All right, so then we did some stuff with angles and triangles and things like that. So for number 1, it says triangle JKE is an obtuse isosceles triangle with the measure of angle E equaling 10 degrees, and KE is greater than JK. So this is a little bit tricky. What does an obtuse isosceles triangle mean?
The angles are obtuse and the sides are equal.
Okay, that means that the vertex angle is an obtuse angle bigger than 90 degrees. All right, so there's my obtuse isosceles triangle. The measure of angle E equals 10 degrees. That obviously can't be the vertex angle, right? So I'm going to call this one down here E and say that's 10 degrees. And then we know that KE is greater than JK. So does the K go here or does the K go here? Right there. Why? Because this side's bigger because it's across from the obtuse angle, right? So this has to be K, and this is J. All right? So now you know what all the rest of the angles are. What's this one here? 10, because it's an isosceles triangle, so those are the same, which means this one has to be 160. So the answer is
B.
B, 160. Okay, number 2. Got this little guy over here. Point O is the centroid. And then it says BY is 18, find BO. So we talked about the centroid yesterday or the day before. What is the centroid made up of? The medians from the triangle. Okay? So one of the things we talked about that is true about the centroid is how does it divide these segments here? Into thirds, yep. This is a third of the whole thing, and this is also a third of the whole thing. So if BY is 18, how much is YO? 6, which means BO must be 12.
Wait, how did you get 6?
Because what we said is the short part is a third of the entire thing.
How do you know?
Because that's something that we discussed earlier in the course. We could go back to that in the book and do the whole proof thing and all that, but I'm asking you to just take this one and accept that and remember it. So if this whole thing is 18, then that means this little piece is 6. And the other part that went with it is that this little piece is half of that piece, so this must be 12. So our answer is 12. Okay? C. Okay.
Let's get this puppy on.
Ooh, that looks like fun. Oh, I understand our problem now with the ones that we skipped. Okay, remember the ones where we skipped them because we didn't have a thing? Here's a diagram that goes with it. So now we can answer those questions. All right, so given that AF is congruent to FC, so FC is hiding over there. Okay, and so this whole piece right here is congruent to that piece right there. And angle ABE, so that one is congruent to EBC. So these two little angles on the top are congruent. Which line is a perpendicular bisector of triangle ABC? Anybody? BF. Okay, definitely not, because BF does not make a right angle with any of the sides of the triangle. When you see the word perpendicular, you should think right angle. So really your two choices are, is it BD or GF?
GF.
Why do you say BD? Okay, because it's one of the two choices and it just seemed like it. The answer is
Oh, good. Yeah.
BGF, because that one is also bisecting this side right here, okay? So a perpendicular bisector has to be two things. It has to be perpendicular to one of the sides, which both of these lines are. But it also has to cut one of the sides in half. And since it says AF is congruent to FC, that means GF must be our perpendicular bisector. And the answer there is GF. Okay? All right, now we can go back and we can answer the questions that we kind of skipped the other day. Oh, we said false, but now we'll know that they're not false. Okay, so which segment is a median of triangle ABC? So which one of these segments would be a median? B, 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 F. Median has the word middle, okay? And since F is in the middle of this side, the median goes from the middle of the side to the opposite vertex. So that answer was BF. All right, and then the last one, which one of these is an altitude of the triangle? BD. Okay, because an altitude is perpendicular to the side, but also goes through the highest point of the triangle. Okay?
Yep.
All right, so that's why those ones were going the other day. What? It is hard to remember all this vocabulary. That's why we're going through it, and that's why little Studer is writing it down so she can study. All right, so we did that one. We did that one. We did this one. Ooh, I should make you guys copy down all that stuff. Yes. Yeah. All right. This is something that you should, Jonathan, this is something you should have maybe written down in your notes somewhere, because this is a relationship that you're going to have to use on the test. And that is that if you have a 45, 45, 90 right triangle, then you know that these two sides are the same, right? Because it's an isosceles triangle. And then what we figured out is the hypotenuse is the length of one of those sides times the square root of 2. Okay? So that's one of the special triangles that we have done a lot with. Then there's also another special triangle. Show me another special triangle. There you are. And that is the old 30, 60, 90. And in the 30, 60, 90 triangle, the short leg, which is across from the smallest side, is x. The hypotenuse is twice the short leg. And the long leg is the short leg times the square root of 3. And it's always easy for me to remember this because 30 has a 3 in it, and square root of 3 has a 3 in it. Okay? And for 45, 45, 90, these two sides are the same, and this has a square root of 2 in it.
Yeah, I feel like a 400 on this test in order to pass it.
Yeah.
Why?
You mean gosh.
Gosh darn it.
Gosh.
Oh, daggone.
That's going to be challenging. Okay, so easy question here. What is the value of x? You know that the two sides are 8. And since it's 45, 45, 90, that means that this one has to be 8 times the square root of 2, which is c. Okay? All right, then for the next one, we're going backwards. Okay? So instead of having the legs and then you have to figure out the hypotenuse, they give you the hypotenuse and you figure out the legs. And so to get the hypotenuse, we multiplied by the square root of 2. To get the legs, you would divide by the square root of 2. And so it would be 5 divided by root 2. That's simplest radical form. So what they're saying there is we do not want a decimal. Okay, so do not go 5 divided by the square root of 2 and write down what? What number? We're going with 6. Or maybe 7.
Well, that one was 7. That one was 7.
All right? Okay, now let's do some more with right triangles. It says the hypotenuse of an isosceles right triangle is 36 units. What's the approximate length of one of the legs? So this is exactly the same as the last problem, except for now they're giving answers in decimals. So we do need to actually figure out what it is. So how do we figure out what it is? Divide by the square root of 2. So this is when you would bust out your calculator. And you would go 36 divided by the square root of 2. I'm sure that all of you can throw out one of these answers right off the top. Which one can you throw out?
Fisher.
Right, because the hypotenuse is the longest side, so it's definitely not going to be that. So if you were in some sort of a freaky guessing situation, you could get rid of that one. What is it? It's A, 25, 25. Okay, 36 divided by root 2 is 25.5. Okay, now we are in 30, 60, 90 land. So 4 is obviously the shortest leg because it's across from the smallest side. So what's X? Now let's do these one first. Oh, they just want to know why. What's Y? 8. Because the hypotenuse is twice the short leg. Okay? And the reason why that's the case is because this 30, 60, 90 triangle is half of a equilateral triangle. Okay? So this little piece right here is 4, and if I made the rest of the triangle, this would be 4 also, which means all the sides of my big triangle are each 8. So this one, this one, 8. Right, so the hypotenuse is twice the short leg. The short leg. Okay, never mind.
X would be 4, wouldn't it?
X would be what?
4 root 2.
4 root 3. I said 30 degrees has a 3 in it. 4 root 3. Jeez Louise. Okay, here's another one. Now they do not give us a picture, so it might be a good idea to draw your own picture. It says if one leg of a 30, 60, 90 triangle has a length of 6 and the adjacent angle is 30, so they're using some trig words on us. So here's my 30, 60, 90. Which leg is going to be 6? Yeah, which leg is going to be 6? The one vertical or the horizontal one?
Horizontal.
The horizontal one, because it says the adjacent angle or the angle right next to it is 30. Okay? What is the exact length, so we're not rounding, no decimals, of the hypotenuse in simplest radical form? Well, we got to bounce around a little bit here in order to figure this out. If this is 6, what's this?
6, 3.
Right, yeah, no, you're right, Blake is wrong. This would be 6 divided by the square root of 3. Okay? And then once I know the short leg, how is the hypotenuse related to that? It'd be doubled, so it'd be 12 over the square root of 3. Okay? Which would be obviously A. Okay, next one says an equilateral triangle has side lengths of 10 feet. Find the length of the altitude AD of the triangle. And so what they're telling us here is that each one of the sides is 10. So if this whole side is 10, what's this little piece here? 5. And now I need to figure out what the altitude is. It's slow for some reason when I do it this way. What kind of triangle do I have here? How do you know that? Because it was equilateral, so you knew that all of these were 60. So if you cut this in half, you get a 30. You guys had a tendency when we went through this to then look at every triangle after that and assume that it was a 30, 60, 90. You can't do that. You need to have some information that tells you that that's the case. And in this case, the information is that this was an equilateral to start with. So all of these are 60, which means this one is 30. So what does that leave you for the altitude? What? I thought I heard it. 5 root 3, yes, because the long leg is always the short leg times the square root of 3. So that's answer choice C. Okay? All right, so now we'll throw in a little word problem there. The pitch of a symmetrical roof on a house 40 feet wide is 30 degrees. What is the length of the rafter R exactly and approximately? And we have to show our work. So what do you want to do with this? Oh, seriously, what?
Burn the house down?
Yeah, we can divide this in half, and then what kind of triangle do we get?
Burn my house down.
Yeah, you guys are real funny. I'm trying to help you. You guys have to take this test. I don't know. You want to
I
be...
passed the test.
Okay, well, the rest of you, you know, well, let's be funny, but how about if we actually try and figure it out? So which leg is that? I don't want to hear bottom. I want to hear short leg, long leg. Which one? Leslie. Which leg is it?
What?
Is it the short leg or the long leg of the 36? Yes, how do you know? Because it's not by the 30. Okay, it's across from the 60, which is a bigger angle, so it has to be the bigger leg. Okay, so this is 20, all right? And it is the long leg, so we always have to know what the short leg is before we can do anything with it. Right, so just like the other ones, that means this is going to be 20 divided by the square root of 3, okay? Which means that R is going to be 40 divided by the square root of 3. All right, and then it says in the answer exactly and approximately. So is that our exact or our approximate one? That's the exact. Okay, so how do I get the approximate one? Not times it by. Do it. You go 40 divided by the square root of 3. And what do you get from that? About 23?
Crap.
23 feet. Okay? So that is fun and games with special right triangles. All right. Then we also have to know, of course, the Pythagorean theorem. If you don't know the Pythagorean theorem, then you should probably write that down as well. But hopefully most of you know the Pythagorean theorem. In a right triangle, a squared plus b squared equals c squared. And then don't forget the converse also, which is that if a squared plus b squared equals c squared, then you know what kind of triangle you have. You know you have a right triangle. All right, so let's do some problems that relate to that. Jonathan, can you stop with your knee? You're making a hole.
Oh, really?
Yeah, really.
I don't know. I can shake it from all the way back here.
Yeah, you can shake it from all the way back there. Shake it, Jonathan. All right, it says David is checking to make sure the door frame that he built has right angles. He measures the width on the floor to be 35 inches and the height to be 85 inches to have right angles. What should be the length of the diagonal? So how do we figure this out? Pythagorean theorem. So we need to go 35 squared plus 84 squared equals c squared. Okay? So what do you get from that? If you square around them together and then take the square root, you get about 91 inches.
Yeah.
All right? So hopefully you guys all understand how to solve that. All right? Yep, should be easy. Okay? Same thing here, except this time since we know the hypotenuse and we're trying to find the leg, what's the equation that I write to use the Pythagorean theorem? 15 squared, I'm getting a lot of different things. 15 squared plus x squared, good, because it's the legs added together, equals 19 squared.
If we failed it.
Okay, please don't do that. And then, so how do you solve that?
19 squared minus
19 squared minus 15 squared, and then you take the square root of that. What do you get from that, Hannah? 11.7?
Alders, we don't have to take this test to pass it. We need the geometry test if you're a sophomore.
If you're a sophomore,
Did you pass the algebra test?
Yeah, if you pass the algebra test.
Yeah, then you only have to pass one if you're a sophomore right now.
Wait, so freshmen have to pass it?
All right, freshmen have to pass both, yeah.
What if you read
Read to what?
we don't have to pass this?
Okay, it's real simple. If you are a junior or a sophomore, you have to pass one of the two tests. Okay, that's fine. If you're a sophomore, you have to pass both. If you're a freshman, you have to pass both.
Why?
When did we find out, like, what scores we got and what we were retouching?
You should know that already. They know the scores already. Okay, I can look that up. Okay? All right. Okay, keep going. We got that?
Why do freshmen have to take both?
Because they decided that they want to make sure that if you are graduating from high school, you're smart. But since that's a sort of a new rule, they had to ease people into it. Okay, so my daughter, for example, senior in high school, didn't have to pass either one. So she did the old Wassel thing when she was a sophomore, but it's changed since then. So you guys that are sophomores and juniors are kind of caught in the middle. All right. Okay, next one. According to the recommended safety ratio of 4 to 1, how high will a 30-foot ladder reach when placed against the wall? What are they talking about? Safety ratio of 4 to 1.
For every four ladders, there's one incident. I don't know.
Anybody have any idea? A has to be, these two things have to be in a ratio of 4 to 1. So the highest that you can put it up on the wall is 4 times the distance that it is from the base. Okay? So how are we going to figure this out?
Okay.
Divide?
That's a check.
Not for a squared. Right. So she's saying if this is x by the 4 to 1 ratio thing, then this has to be what? 4x. And then they told us already that this right here is 30. Okay? And so that gives us the ability to use the Pythagorean theorem now. So this squared down here is obviously x squared. What is 4x squared? In other words, what is 4x times 4x? 16x squared. Don't forget you have to square the 4 as well. And 30 squared is 900. Okay? Well, what's x squared plus 16x squared?
16x squared.
17x squared.
What? How's that?
X squared plus 16x squared is 17x squared. How does that happen?
You just add another x to the 16.
Yeah, because this is like 1x squared.
Oh, okay.
Okay. All right. What do I do next?
Divide by 7.
Divide by 17.
X squared and times square root of that.
And what is the square root of that?
And divide by
What
17.
What is it? 7.3. Okay. But that told us how far the ladder could be from the base. We want to know how high it can be off the ground. So what do you do to that to figure that out? Multiply by 4. So what's 7.3 times 4? 29.2. So 29 feet 9 inches or 29 feet 1 inch?
1 inch.
29 feet 1 inch is closer to 29.2. Okay? Okay, let's try and maybe just wrap up this section. Okay, what is the length of the missing side of the triangle? You guys can all do that, right?
Yeah.
14 squared plus 48 squared equals, and then you take the square root. And if you do it correctly, I think you come up with 50. Is that true? Anybody do it? Well, you can check my work. 50? Okay, good. So that's easy Pythagorean theorem. Okay, Alice drew 4 triangles and measured each side length because Alice knows how to have a good time. Which side lengths would form a right triangle? Anybody know?
Is it, yeah.
5, 12,
No,
what?
9, 12, 24.
9, 12, 24. So you're going to say 9 squared plus 12 squared equals 24 squared. Well, let's see if you're right. 9 squared is 81, 12 squared is 144, and 24 squared is 596. Anybody?
Yeah, 576.
576? Okay. Does 81 plus 144 equal?
No.
Yeah.
Nope. So, sorry, Alice does not want to hang out with you.
It's a B.
Okay. You're going to go with B, 5, 12, 15. So 5 squared plus 12 squared, does that equal 15 squared? Go! 5 squared is 25, 12 squared is 144, and unfortunately 15 squared is 225. Okay, does 25 plus 144 equal 225? Nope. So that's out.
3, 4, 6.
So it's going to be this one right there. Yeah, 5, you know it's not 3, 4, 6, because what's that one? It's supposed to be 3, 4, 5. So that's definitely out. 10, 24, 26 is actually a form of a common Pythagorean triple, which is 5, 12, 13. Okay? All right, is this the last? Yeah, we'll do this one and then we'll call it.
5, 10.
Okay, so this is a problem that we've done at least twice directly from our own textbook. A box in the shape of a rectangular prism has a height of 5 inches, so this guy right here is 5. Okay, a length of 8 inches, so this is 8. And a width of 6. And we need to figure out the length of the diagonal D. So what do we do first? We find x. I already know what it is. What is it? It's 10 because it's a 3, 4, 5 right triangle where everything is doubled. So this right here is 10. Now how do I use that to find D? 5 squared plus 10 squared equals D squared. So those would add up to be 125. And then how do I find out what D is? Take the square root. And so that would 11 point something, but they want the nearest full inch. So that's going to be 11. Okay? All right, will you make sure that your name is on the work that you did today? Pass those forward.